Hi, welcome back to the third and the final video of the 2024. I'm just going to write it here to 2024 paper 1 Edexcel. So I'm going to start with the question number 15. I'm hoping you have paused and tried it yourself. So now this one is asking you to add to the diagram how the electric field between the two plates changes. So it's 3 marks. To be on the safe side, draw 3 lines. So this is a positive plate, so starts from the positive plate, ends on the negative. Now, if you don't put the arrow, you don't get the mark. If your lines are not equally spaced, you don't get the mark. So you need to have equally spaced arrowed lines. Explain why the reading of the voltmeter indicates that the EMF of the power supply. Right, so this voltmeter is just going to read the EMF. And why is that? Because the current is 0. There is no current in the circuit, hence no potential drop across any resistance. So V will be equals to E as current in the circuit is 0. So no drop across internal resistance. Right, so you the 2 marks comes from the first mark's current is 0, no drop across internal resistance. Let's do the next one. The power supply increased, of course, and then the spark starts. Now there's a spark so the spark has come because the field has increased this strength and the air has become conducting. Minimum potential difference. So using E equals to V over D. You can calculate V as E times D. So 10 to the power 6 divided by distance times distances. Convert units. Be careful of the units. 10 to the power minus 3. That is around 6,000 volts. Okay, quite easily done. Easy. It's a simple question there. Now, why the voltmeter reading decreases significantly when sparks are produced? So see, now what it has done is, if you've understood this question, why the reading is equal to EMF, fine, because there's no drop. Now, why the reading has dropped? Obviously, now because yes, you're right, because there's no current. There is current. The current is in the form of the spark. So this current comes from sparks. So because there is a current, why is a current? So there is a drop. There is a drop of IR, hence using V equals to E minus IR, V is less than E. That's it, simple. Understand, if you understand. So see, as I've been telling you, we're not here to see the mark scheme, we're not here to see the answer, we're here to learn the concept. The concept in this question is terminal voltage is equal to EMF when there is no current. The minute there is a current in any form, the terminal potential difference would be less than the EMF. That's it, done, well done. Let's do the next one. You pause, I will read. This is asking, show that the resistance, I have voltage, I have power, so resistance, I'm just going to use this equation, okay? P equals V square over R. I'm sorry, what happened here? So R gives me V square over P. V is 1.5 squared divided by 0.5, okay? Solve it and you would get the answer, okay? Now, one simple reminder, if you are facing trouble rearranging the equation, which some of us does, it's all right, just message me. I'm going to make a video which is going to show you how to rearrange the equations, okay? It's better than losing marks in the final exams. Okay, let's try this one. The student wishes to control, do you want me to give the answer for the previous one? Wait, let me give you the answer for the previous one. The answer that I got for the previous one is 4.5 ohms. Okay, let's do this one. So now see, the trick here is this is much larger than the resistance of the filament bulb. This larger value will stop any change across the bulb. So because potentiometer has a larger resistance, the slider controls the potential of the bulb. So when the slider is here, no voltage across bulb. When the slider is here, entire voltage across the bulb. So I'll start by not writing how it is increasing, and then I'm going to explain it. The first point. Moving from A to B, the brightness increases. From A to B, brightness increases. Okay, done. Now I'm going to explain why. At A, the potential difference across bulb will be 0. Okay. At B, potential difference across bulb will be 1.5 volts. So we have explained. So you got 1 mark, second mark here, third mark here. So as you move from A to B, the potential difference across bulb is increasing. Bulb across bulb increases. Done. Okay. So potential difference across bulb has increased. So what has that resulted into? So the brightness of the bulb has increased. So why this is happening? Why this is happening is because resistance A to B is decreasing. That's it. Done. Okay. Let's try the next one. You have tried. I'm going to do this now. Complete this. So, now, let's see. Let's see if you understand the behavior of a capacitor. When you close this, the minute it is closed, your capacitor has no charge initially. So because initially your capacitor has the charge on capacitor is 0, so potential difference across capacitor will be 0. So no potential because Q is equals to CV. No charge, no potential difference. Now, so entire voltage of 1.5 is across the bulb, right? And there's no potential difference across this one, so the entire goes to this is across the bulb. So the bulb is what? Bright. So initially the bulb is very bright. Okay, so done. So we have explained the initial condition. Now as the capacitor charges up, because the capacitor would charge up, so the capacitor, third point, as time passes by, or let's just, okay, so capacitor gets charged up, capacitor is charged, potential difference across capacitor increases. So this is increasing, hence potential difference and brightness of bulb decreases. Now this particular question is also looking for you to for whether you understand the concept of time constant or not. So the fourth mark would be when you talk about the time, like, so that's why I was waiting here when I was thinking whether should I write time constant here or not. Okay, so I'm going to just write fourth point to make it more clear for you. So what's the time constant for this circuit? Do you know this is a formula for time constant? Resistance, let's go, what's the resistance here? 5 ohms, and capacitance is 1.2. So 6 seconds. This is a time constant. Now what's a time constant? If you know that by definition, in 6 seconds the capacitor is charged to 37% of its initial value, so around 5 to 6 time constants, around 30 seconds or so. In about 30 seconds the brightness drops significantly. That's it. So you're talking about the value of the time, particularly. That's why they've given you all the values, isn't it? You have the value of the resistance of the bulb, you have the capacitance of this. You need to be using it somewhere. All right. Okay, let's do the next one. Pause, do yourself. If done, let's start. 17th. Over 100 years ago, Rutherford supervised a series of experiments using source of alpha and thin gold foil. Describe the model. Oh God, this could be anything simpler, right? Describe the model. What do you think? The first point. Did you say atom is almost empty? That's your first mark. With all of its mass at a small center. And what is that small center known as? You're right. Known as nucleus, which is very, very small. Oh, you've already written that. I'm just writing it to make my examiner happy. Which is very small. Which is very small. Which is smaller than the entire atom. That's it. Done. Okay. Let's do the next one. Now, what's happening? He figured out what's a charge also, and how did that happen? That's not a part of GCSE. The previous question was a part of GCSE. Now, this one you need to understand as an A-level student. So what's happening here is the initial kinetic energy of an alpha particle is this much. So I have an alpha particle with some initial KE. It is launched. Textbook states that the alpha particle with this energy would be brought to rest when it reaches at a distance of this much from the center of gold nucleus. So I'm just going to make a gold atom here. This is my nucleus. What is the charge on the nucleus? That's your first mark. Okay, the charge on the nucleus would be, what do you think? 79 times the charge of an electron or proton, same charge. I got the charge. Now this charge, now why would the alpha particle stop? Why could not it go at a distance higher than 5 into 10 to the power minus 14 meters? Why would it stop here? Remember, I'm going to take a different color. Remember, when your alpha particles, this one is exerting a repulsive force. Okay, now this is a difficult question. They're exerting a repulsive force on this alpha particle. So eventually, which is trying to move in this direction. So this force is trying to stop it, and it would be finally stopped at this point. So how are we going to do this? We're going to conserve energy. So work done by this repulsive force is change in kinetic energy of the alpha particle. Now change in the final kinetic energy of the alpha particle would be 0. So the change is nothing but KE, initial KE, which I know as 7.3 10 to the power minus 13 joules. And now work done by this force. I'm going to calculate the work done using this formula QV, potential, charge times potential. That's charge of alpha particle to 2 times the charge of proton, 10 to the power minus 19, because it has 2, times the potential. Now the potential at this point is produced by the nucleus, which is V. I'm going to just write V here is K Q over R. So you substitute the value of K from your equation sheet. Q is 79 times 10 is over the distance is 5 times 10 to the power minus 14. So you calculate, I calculated it earlier. Let me just give you the value in case some of you have calculated it. I am getting my potential as I did not calculate it. Okay, I'm just going to just write this. So you plug in the value here, 2 times 1.6 10 to the power minus 19 times k times 79 times 1.6 10 to the power minus 19 over 5 times 10 to the power minus 14. If this comes out to be equal to 7.3 10 to the power minus 13, which I got it as, I plugged the value as this, I got nearly equal to 7.2 something 10 to the power minus 13. So hence the textbook is correct. So the idea here is that you calculate the work done by using charge times potential and is equal to change in kinetic energy. The alpha particle finally stops here, and the alpha particle finally stops here, so the final kinetic energy is 0, and you just multiply charge with the potential. That's it. All right, so you get 1 mark here when you write it correctly. You get 1 mark here when you do this correctly, and then you get 2 marks on your calculations. Are you okay with that? Okay, let's continue then. Determine the initial momentum of the alpha particle. So you do have the initial kinetic energy, so you can use this formula. Kinetic energy is equals to p squared over 2m. So then you times kinetic energy with 2, and mass of alpha particle is equals to p squared. I'm going to just give you the values. The kinetic energy I had was 7.3 10 to the power minus 13 times 2 times 4 because 4 charge alpha particle is 4 into 1.67 10 to the power minus 27 mass of proton, and then you take a square root, so that gives you p, which I was getting around 9.9 10 to the power 20. Of course, don't write unit, don't get the mark, kg meter per second. That's it. All right, let's do the next one. My battery is about to die for the laptop. I'm just going to quickly go through this. What is meant by elastic collision? Please remember, pause and play. Elastic collision is when, what is it, conserved? Perfect. Kinetic energy is conserved. Remember, momentum is always conserved, whether it is elastic or inelastic. What happens to the atoms in the gold foil? Obviously, if this is going in colliding, it's going to recoil because to conserve momentum. That's it. Okay. Now these are the basicness. This is the basic question. The tough one was in between here, the B. Okay, now let's do the 18th one. Pause, play. Let's do this. How this arrangement can be used as a regenerative brake. Now this is basically asking how current is produced by the armature coil. So same points first. What's the point? As it is moved, it is changing the magnetic flux. As magnetic flux is changed because of the movement of the coil, you have to give the reason why the magnetic flux is changed. Because of movement of the coil. So change of magnetic flux produces what? EMF, okay, and EMF is produced, and because the circuit is closed and the induced current is produced. Now this induced current, what does it do? Then according to Lenz's law, the induced current opposes the cause that produces it. This current opposes the cause that produces the current. What was the cause? The cause was the movement. So it opposes the movement. So how does it oppose the movement? by breaking it. Okay, so this is called regenerative braking.